everyone, I'm Gwen from Nile, and today I want to show you how I'm building a multi-tenant AI native application using Python and Postgres and some other stuff. Because this is a quick start, we're going to build the traditional to-do list, but it is going to have a twist. First of all, it is multi-tenant, and second of all, it gives an estimate for every task that you create when you create it. Here we go. The world's smartest to-do list quick start is about to start. So first of all, let's talk about our tech stack. We're going to build it in Python. I'm going to use Fast API for the REST API. I'm going to use SQL Alchemy as my ORM. SQL Alchemy will connect us to Nile. Nile is a serverless Postgres, so it's our database. And it gives us features like tenant management and tenant isolation. So it will be multi-tenant and secure and have privacy right out of the box. It also has PG Vector built in. So I'm going to show you how we're going to use PG Vector for our AI features that make TaskGenius such a genius. For the AI, I'm going to use OpenAI client. Okay, so we always start building applications from the data model. In order to build multi-tenant AI native to-do list, we're going to need a table for tenants. Tenants have users, and users are the ones that log in and use the application. So we're also going to have a table for the users. And then we're going to have a table for the to-dos. And to keep things simple, I'm going to use the same table to store the to-do, the estimate, and vector embedding that we're going to use in the AI feature. So we'll have a very simple data model. Let's build it. I'm going to create a brand new database for this. We'll call it Compassionate Sun, and I can pick a region. I'm in San Jose, so we'll go with US West 2. Make sure you pick a region close by. Everything is much faster when you don't have to go through the entire world as network delay. Okay, so as we said, we're going to need a table for tenants, which we already have. It is built in right into Nile. And we are going to have to create our to-dos table. Let me grab the SQL. Now you can see a few things here. First of all, we have a tenant ID. This makes this table tenant aware, which means that it gets split between Nile's virtual tenant databases. You can think of every tenant as having their own small database with their own to-dos and their own embeddings. And when a user signs up, it gets a connection, the application gets a connection to that specific tenant database. I'll show you how to do it with SQL Alchemy. But the key thing is that every row belongs to a specific tenant. It's in their private tenant database. Nobody else is going to see it, which is pretty awesome. And then I have the to-do title, I have the estimate, those are just strings, and I have the embedding. This is vector type. It is part of PG Vector, which is an extension but is built into Nile. And the important bit is that the size has to match the size of the model that generates embeddings. Most models say, I'm generating embeddings with that many dimensions. This is what you need in your table. I'm using the Nomic Embed Text version 1.5. It generates 768 dimensions, so this is the size I use for the column. Okay, we have the table, and before we leave the UI, one last important bit, we need to grab credentials for the database. And we'll grab the entire connection string, since this is the simplest, especially with SQL Alchemy. So I click Generate Credentials, copy. Don't forget to keep them safe. Anyone with this connection string can connect to your brand new database. Time to set up the application, run it locally, see that it works, and then I'll go over the code and explain to you how we built it, how it works, how you can use Nile and other frameworks to build your very own AI native multi-tenant application. One more important bit, you're going to need some vendor that is OpenAI compatible, which is most of them, that runs both embedding models and conversation or chat models. And you're going to need to have an API key and a URL for that vendor. I'm going to show you how I use it with Fireworks, but whatever works for you, as long as you have a URL, an API key, and the vendor is OpenAI compatible, this is all going to work for you out of the box. So first of all, let's clone the example. Okay, and now that I have the example, let's create our environment file. So this is where we put the database URL that I told you to grab from Nile. One thing to note, the one we grabbed from Nile has pSQL at the start, and it says Postgres instead of PostgreSQL because SQL Alchemy is slightly different that way. So just make sure you edit yours correctly. Okay, so make sure you have yours. For the AI estimates, this is where you put your API key. This is where you put the URL that you grab from your vendor, especially if it's not Fireworks. And then your vendor may have different models, and it will definitely have different names for those models. So even though you may be using Llama exactly the same way that I do, if you don't use Fireworks, it is going to have a different name somewhere around here. So make sure that you grab models that actually exist for your vendor, both for the AI model and for the embedding model. And also note that this example uses the same vendor for both AI and embedding. Some vendors don't have any embedding models. So either don't use the vendors that don't have embedding models, or you'll have to modify the code a bit to use two different clients and set them up separately. Not huge deal, but just be aware. Now I'm going to put my AI API key here, but I am going to hide it from you, so don't peek. Okay, and we're done saving our environment variables. Now we want to set up a Python virtual environment. So we won't mess up everything else that I'm doing. If you haven't used Python virtual environments before, you can skip this step, but it's highly recommended. Okay, and in my virtual environment, I'm installing all the dependencies. This is why I wanted a virtual environment, so I won't just mess up whatever else I'm working with all those dependencies. And now there's two ways to run the application. You can just run the API backend on its own, and this is fine. Or we also have a UI. That's how we showed you the app earlier. I'm going to run it with the UI. Up to you if you want the UI or not. Okay, and now that I have the UI, let's start the Python web app. Okay, and since it's a brand new database, I have to sign up. And I'm just going to make up a random username because it's a demo. Okay, and I can create a new tenant. Okay, it doesn't have any to-dos yet, so let me create a new task. And it says that it's going to take 4 to 6 hours. You can see that it's based on reference that I provided, which is an empty list because this is my first task. But as I create more and more tasks, it's going to use old estimates to give new estimates. So if I say now record a video about kittens, it may use the existing estimate to give a new one. Or at least it stopped complaining that my list of estimates is empty. And if I look behind the scenes, you can see that I'm telling it to use similar tasks as reference. And then I'm providing here, it picked up the old example that it has and gives it as a reference. This is what the application is doing. Another thing we can do here is to go back to Nile, and so you can see here that I have the two tasks, I have the estimate, and if I scroll all the way to the end, you can see the embedding. Now that you've seen my amazing app and we created the tables and you know how to run it, I'm going to do a quick code walkthrough, and I'll show you how to work with Nile's tenant databases with SQL Alchemy. And then I'll also show you how to use Nile and pgvector to give AI-based estimates for your tasks, or anything that you want to build for your application. Okay, so this is the main class of my application. And as you can see, after I instantiate Fast API, the first thing I do is add middleware, and I add a tenant-aware middleware. Let's go take a look at the tenant-aware middleware. What a tenant-aware middleware does is basically take a look at the headers of our REST and also at the cookie. And out of the header and the cookie, it grabs a tenant ID and it grabs a user ID, and it sets them in a context. And those are context variables, which means that after it processes a request and grabs the tenant ID and the user ID out of the request header and request cookie, everything else that comes after that, if it tries to access context variables, it will always get those values. Even though I have maybe a lot of different requests and a lot of threads and contexts that are each handling something else, everything that runs after this middleware run handling the same request will have the same context variable. It is thread safe, if you're familiar with this concept from elsewhere. After we did this, what do we do next? Let's take a look at one of the places where we handle the request, because the next thing is the request handler. And you can see that we have several APIs. We have create a tenant, list tenants, create a to-do, list a to-do, essentially. Those are the things we do here. And you can see that there is a difference between them. So when I create a to-do or list the to-dos, I'm doing it for a specific tenant. So I have to do it in this tenant's private database. But when I am creating a tenant or listing tenants, I'm not doing it for a specific tenant. I just want to list tenants. I just want to create a tenant. I don't have a tenant yet. I cannot do it in a tenant database. A tenant doesn't exist. So we have two different types of sessions that we're getting from SQL Alchemy. We have a global session, which is just a plain old normal SQL Alchemy connecting to Postgres, running queries. It runs across all tenants. This is how we create a tenant, and this is how we list the tenants. And then we have things that we do for a specific tenant. For example, create a to-do or get all to-dos. Those we do with a tenant session, which is a session that is specific to the tenant that we are working with. We know which tenant we're working with because, hey, we had this middleware running a second ago. And this tenant session, it is basically create a normal session and then grab the tenant and the user ID out of the context that we previously set in the middleware and tell the database, hey, for this following transaction, you're using this tenant ID, you're using this user ID. And Nile will enforce everything for you, routing to the correct database, making sure that the user can actually access the tenant, like everything else is being handled for you. If we go back to the application, the only thing I have to do when I get a to-do is basically write the query. So I'm doing a select here. And you can see that I'm doing select from all. I'm not doing any workloads. I don't need to. I'm connected to this tenant database. Every to-do here is to do for this tenant and I want to list them. And also note that I am not grabbing the embedding because I really don't want to show it and I don't even want to return it in the REST API. 768 floats is very large. No reason to waste time, bandwidth, memory, anything on this thing. So I'm specifying exactly which fields I need here. Now that we understand how to work with Nile and SQL Alchemy and Fast API, I'm going to show you how to do the AI bits. All the AI bits happen when I create a new task. So we just have to look at the post/API/to-do handler. And let's see what we do there. So the first thing I do is to get an embedding. And you can see here that what do I get an embedding for? I'm getting embedding for my to-do. And I also have an embedding task. This is something that some embedding models do. They say on the nomic documentation, they say that they have different types of tasks. And if you use the correct task and tell the model what you want it to embed for, what are you going to do with this embedding, it will actually perform better. So I'm using it per their documentation. I have no real way to know if it performs better. I haven't compared it to anything, but I'm following what they told me. So I'm calling get embedding. Let's take a look at that. And you can see here that I'm using OpenAI client. I imported it way up there. And I am setting it up with my URL, which in my case points to Firework, and I'm setting it up with my API key. You should use yours. And then I'm also setting it up with my model. Again, use yours. And then I am passing in the strings that I wanted to embed, but with a twist. I'm saying that if the model is nomic, in my case it is, then, as I said, it likes to have the task. It wants to have first the description of what you wanted to do with the embedding, and then the text that you want to embed. And they say that it has been specifically fine-tuned and trained. So if you tell it that this is a document that you're going to use to store and then search for, it will create as an embedding that is better fit for that, versus if you tell it that you want to use it to search for other things. So we're actually going to embed every to-do twice. First, in order to store it, and then in order to use it to search things that are already stored. So I hope it makes sense. So we said it's going to be a search document. We called create embedding. We got back a response. Note that I have to do some massaging to the response. So the response is apparently an object. It has an array called data. In the array called data, every element is also an object, and it has an element called embedding that if I pull that out, I actually get my actual vector. Since this is very specific for every client, and I don't know if at some point I will want to use something other than OpenAI client, and if I'll go to a vendor that doesn't support OpenAI client or whatever, I wrapped all of it in get embedding. I'm passing in the text to embed and the task. I am returning just the vector. So if I ever switch anything, I will figure out and encapsulate all the logic of how to pull out the vector in here. Nothing else in my code has to worry about it. Okay, I got the vector. Now what? So since this is the vector, the embedding that will be stored in my database that will later be searched, I'm going to take my new to-do item that will get stored in database and set the embedding to embedding. Now I'm going to go and search for similar tasks. Note that every single one of my AI-related methods is in a big library called AI utils that you can just copy and use on your own in any application that you want. So in the get similar tasks, the first thing I do is generate yet another embedding. Why? Because I'm using a model that claims to do better when you create an embedding for a specific task. First time I embedded, it was for storage. Now I'm embedding for searching things that are already stored. So I'm telling it, please embed it as a search query, and I get back a vector. Now what do I do with the vector? Well, I query the database. So I'm using SQL Alchemy here, and I'm saying, okay, take the session. Note that the session that I passed in is not the global session, it's the tenant-aware session that I created. So if we go back, you can see that I'm passing the session, and this is get tenant session. So I'm passing in the session that is connected to the tenant database, which is why I filter only for short cosine distance. Basically filter out if embedding vectors are so far away as to be irrelevant. Anything over 1 basically means those things are completely unrelated to each other. Even 1 means they're unrelated to each other. So I'm searching for things that are at least somewhat related to each other. So I'm filtering by the vector distance. And then I'm also sorting by the vector distance and getting the 3 closest. So what this will do, it will give me the 3 closest to-dos to the ones that I used for searching, assuming they are at all related. If there is nothing even remotely related, if I am to put in a task that is completely blah, 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 and there is nothing like it in the database, I will get nothing, and this is fine. I will just have an estimate that is based on nothing, which is better than an estimate based on absolute garbage. The reason this looks really nice and SQL Alchemy works so smoothly with my vectors is because I use the PG Vector SQL Alchemy client. If I go to the models, you can see that from PG Vector SQL Alchemy, I'm importing vector, and then I'm defining the data model with the embedding that actually uses the vector object from PG Vector. Highly recommended. Back to my AI utils. I run this query. I'm getting back a title. I'm getting back an estimate. Now what? Well, now I take all the similar tasks with their estimates, and I'm calling AI estimate. So this takes the title of my to-do, and it takes the similar tasks. What does it do with them? Again, it connects to the model in my I vector, and now it is calling a chat model. And I'm doing the whole prompt engineering thing. You're an amazing project manager. I need you to estimate my task. How long do you think it's going to take? I have a few similar tasks with estimates. Here are the similar tasks that I just grabbed from my database. Please respond with just the estimate, no blah blah. And as you've seen, it responds with an estimate and no blah blah, assuming it has tasks. Otherwise, it complains that it didn't get any tasks. What do I do with this? Well, it's very simple, right? I save it to the database, and then I also return it in my API so my UI can display it. So you can see it was like 3 steps. You generate an embedding, you get a similar tasks. This is one query. You get the AI estimate. So it's one query, 2 API calls, and you have a smart estimate. Sometimes embarrassing how simple AI can be, especially if you use good tools and good clients. So that's it. We're done. What do you do next? Well, first of all, if you haven't tried to run it on your own, you probably should. You can try it with Fireworks. You can try it with your own vendor. Then you can try playing with the prompt. You can try playing with different embedding models. Don't forget that if you have some data and you need a new embedding model, you have to re-embed all the data. So this is kind of a toy example. So I stored the to-do and the embedding together. In a real scenario, I would put the embedding in a different table exactly so I can actually generate new embeddings if I want to try a new model. The chat model, on the other hand, you can try whatever you want. I used Llama. You want to use GPT-4o mini? Go for it. You want to use the new Gemini things that everyone is talking about? Go for it. There is always a new model to check out. Other than that, if you go to the Nile documentation, we have tons of AI examples. We have tons of ideas for applications you can build. Smart HR, smart expense reports, smart Slack, smart travel agent. The sky's the limit. If you go and build a cool application using Nile, definitely drop me a line. You can use the Nile Discord or you can ping me on Twitter. I would absolutely love to hear what you've built. If you like this video, we have many like it. I keep putting up new videos out there. Don't forget to like and subscribe. And I hope you have a great time building AI native applications and sharing them with the world.